Hello everyone, today in this video we are going to talk about a vernier caliper. So after this video you should be able to calculate the vernier constant and the zero error of a vernier caliper and take the measurement using a vernier caliper. So a vernier caliper is a device to measure length. Using this part we can find the inner diameter of a beaker. Using this part we can find the length or diameter of an object, and using this part we can find the depth of an object. And this is a diagram showing the function of each part of a vernier caliper. So in vernier caliper we have two scales. This scale is called main scale. So we have two main scale, one is in inch and another main scale is in centimeter or millimeter. And we have one more scale out here, and the name of this scale is vernier scale. So in this picture you can see the magnified part of a vernier caliper. So the upper scale is main scale and it is in millimeter or centimeter, so each division is 1 millimeter, and the minimum length which we can measure from the main scale is 1 millimeter or 0.1 centimeter. The measurement below 1 millimeter or 0.1 millimeter is measured by vernier scale. So main scale can measure up to 0.1 centimeter and the remaining length is measured by vernier scale. So suppose the length measured by this vernier caliper is 2.34. So suppose the length measured by this vernier caliper is 2.34. Now this is the main scale, and we know main scale can measure up to 0.1 centimeter. That means 2.3 comes from main scale reading. So 0.04 cannot be measured using this main scale. So to measure this 0.04 centimeter we use vernier scale, and vernier scale can measure up to 0.01 centimeter in case of this vernier caliper. So the front part is called main scale reading and the back part is called vernier scale reading. In order to take the measurement using a vernier caliper, we should know what is the unit of one division of vernier scale. So for main scale we already know it is 1 millimeter or 0.1 centimeter, but for the measurement of vernier scale we don't know. So first we have to find the least count, that means the measurement of smallest division of vernier caliper. So let's find the least count of this vernier caliper. So least count is 1 main scale division minus 1 vernier scale division. And if you see the vernier scale, we cannot tell how much is the one division in vernier scale. So before taking the measurement we should know the vernier constant of this vernier caliper. Vernier constant means the smallest measurement which a vernier caliper can measure. Least count means 1 main scale division minus 1 vernier scale division. So 1 main scale division is 1 millimeter we know, but we don't know how much is 1 vernier scale division. So 1 main scale division is 1 millimeter, and if you see there are 10 vernier division, and 10 vernier division is equal to 9 main scale division. Out here you can see 10 of this vernier scale is equal to 9 of this main scale division. So I can write this. So now one vernier scale division is 9 by 10 main scale division, and 9 by 10 is 0.9, and 1 main scale division is 1 millimeter. So 0.9 millimeter is the vernier scale division. Now I'll use this formula to find the least count. So least count is equal to 1 main scale division, that is 1 millimeter, minus 1 vernier scale division, that is 0.9 millimeter. So 1 minus 0.9 millimeter is 0.1 millimeter. So the smallest measurement we can take using this vernier caliper is 0.1 millimeter. So if you convert it into centimeter, it is 0.01 centimeter. Now to take the measurement using the vernier scale, we have to to measure a length using a vernier caliper, we have to make use of both scales. So total reading is equal to mean scale reading into vernier scale reading. So, and vernier scale reading is n into least count. N means number of vernier division. So total reading is mean scale reading into number of vernier division into least count, and least count we have already found, that is 0.01 centimeter for this vernier caliper. Now in next slide we'll learn how to take measurement using this formula. So now to take the measurement, we have to keep the object in the vernier caliper and we have to see the reading. So to take the measurement we need one table. So table consists of main scale reading, vernier division, vernier scale reading, that is n into least count, and least count we already know 0.01 centimeter, and the total reading is the sum of main scale division into vernier scale reading. So to know the main scale division we have to see the zero of vernier. So wherever the zero of vernier is pointing is the main scale reading. Zero of vernier is out here, so the main scale reading is 3.1 and 3.2. So this is 3.1, 3.2. So main scale reading is 3.2. So I'll note down the main scale reading division out here, 3.2. Now to know the vernier division, we have to check out of this 10 vernier division which is coinciding with the main scale division properly. So if you see the sixth one, this one is perfectly coinciding with the main scale division. So out here you can see 1 2 3 4 5 6. So we start counting from 0. Vernier scale division is 6. Now I'll find the vernier scale reading. That means I'll multiply this 6 with least count, and least count is 0.01. So I don't need to show the multiplication out here, so it will be directly 0.06. Now I'll add this 3.2 and 0.06, main scale division plus vernier scale division, and if you add these two you will get 3.26. So one more reading. So now in this case the main scale division is, we cannot see 3 this side, but this is 3.5, 3.6, 3.7, and it is not touching 3.8. So we have to consider the lower one if it is not exactly coinciding with the main scale. So I'll take 3.7. Main scale is 3.7 and vernier is the one which is exactly coinciding with the main scale. So this is the one. So vernier scale reading is the 9th division. So I'll multiply with least count. So the reading is 3.79. So similarly out here now you can see it is exactly coinciding with the 8. So I should take 8, and in this case you can see there are 2 vernier division which are coinciding. So we have to take the lower one, because if you take this one, so your reading will be 8.09, and 8.09 will be somewhere out here. So but our reading is exactly 8, so the measurement should also come exactly 8. So if you take 9, then it will come 8.09. so we should not take 9, we should take 0, because the reading is exactly 8, and we can see the reading is exactly 8. So we should not be taking this one. So vernier is 0, so the reading is 8. Suppose now we are measuring the diameter of this ball, so we measure it 3 times. So first case you can see this is 7.9 and vernier is number 6, 7.9 and number 6. And in second measurement, so we'll take out the ball and we'll put the ball back in the vernier caliper and we'll measure it again. So out here it is exactly coming to 8. So if it is 8, I have to take the vernier to be 0, so it is coming 8.0. So now in third case, main scale is 8 and vernier is second, so 8 and 2. So out here you can see it has not touched 8, that's why I have taken 7.9, but out here it has exactly touched 8, so I'm taking it to be 8. So now I've got 3 readings, so I have to find the mean of these 3. So mean will be 7.99. So if you have to measure diameter and height of a cylinder, that time you will make this kind of table where we have diameter and height in the same table, and we can find mean diameter and mean height. So next is zero error. So let's understand the zero error by taking an example of a pencil. Out here you can see one end of the pencil is at 0 and another is at 4. So the total measurement is 4 centimeter, and out here I am not having any error because the length of the pencil is 4 centimeter. Suppose in second case I am taking the same pencil but I am measuring from 1. So the length of the pencil I am getting is 5, but the length was 4. So there was error. So I got 0 error because I have not started with 0. So if you don't start with 0, you will get some error. Now you have to reduce this error. So we can subtract 1. So because I have started from 1, so I can subtract 1 to get the original length of the pencil, that is 4 centimeter. So in third case, suppose I start with 2 of this side, then the length of the pencil I'll get is 2 centimeter, and the error was -2. It was going towards the negative side. So I'm getting only 2, but the actual length is 4. So what should I do? I should add this 2. So 2 minus the error was -2. So I'll write -2. So now I'm getting the 4 centimeter. So this is the zero error. Zero error means whether you are starting from the reference point or not. And in vernier caliper also we get zero error. If 0 of main scale and 0 of vernier scale do not coincide with each other, then we get zero error. And there are 3 types of errors. So one is no zero error. That means main scale 0 and vernier scale 0 coincide with each other. This time we don't get any error. And if the main scale 0 is towards the right side of the main scale 0, that time we will get positive error. And if the 0 of vernier goes towards the left of the main scale 0, that time we get negative error. So this is 0, that means if it goes to negative side, we get negative error, and we have to subtract the error every time. Find the zero error. First we have to take the scales to the minimum position without keeping any object. So we have to keep the vernier caliper like this, and we have to take the readings. So suppose we have the positive errors like this, so we have to find the errors 3 times and we have to take the mean of 3 errors. So right now you have to see the vernier scale reading. So out here the second scale of vernier is perfectly coinciding with the one of the division of the main scale. So we have the second one, so I'll write 2. And vernier constant we already know, 0.01 centimeter. So zero error is positive error plus 0.02. And again we'll open the vernier caliper, and again we'll take the scale to the minimum position, and again we'll check the reading. Now this time it is coming to third. So error is plus 0.03 centimeter. And in third time again we have to do the same, and this time it is coming to fifth one. So I'll write 5, and now we have got 3 errors, so we have to find the mean of these 3 errors. So mean of these 3 is 0.033. Now out here we have negative error. The 0 of vernier is going towards the left of the 0 of main scale. So for negative 0 error we have to start counting from 10. So out here you can see this is the vernier division which is perfectly coinciding with the main scale division. So this is number third. So I'll write, so this is number third, so I'll write number 3. and error is minus 0.03 because it is going towards the negative side of this 0, so I'll write negative error. And for this, you can see number 4th of the vernier is coinciding with one of the division of main scale, so 4 is the error. In third case, we can see first one is coinciding, so I'll write 1. So I'll find the mean of this 3. So mean of this 3 is minus 0.026 centimeter. Now after finding the errors, we have to subtract the error. So suppose this is the measurement taken with a vernier caliper with 0 error. So suppose if I have positive error of 0. So suppose this is the measurement taken with a vernier caliper, and suppose the vernier caliper has the positive 0 error of 0.033 centimeter. That time mean diameter is 7.99 centimeter and error is positive error, that is plus 0.33 centimeter, and now the corrected diameter is 7.99 and I have to subtract the error, so error is 0.033. so your corrected diameter or real diameter is 7.957 centimeter. Suppose in another case the vernier caliper has the negative error of minus 0.026 centimeter. That time also I have to take the mean diameter, and 0 error is minus 0.026 centimeter and corrected diameter is 7.99 minus, so I have to subtract the error, and error is minus 0.026, so minus and minus become plus. The corrected reading is 8.016 centimeter. So this out here I have shown the correction of both negative and positive error, but in real case we can have only either positive error or negative error, or sometimes we may have 0 error also. Now let us see the steps to use a vernier caliper. So first we have to find the vernier constant. Second, we have to calculate the 0 error. So in some of the vernier caliper we may not have any error also. Sometimes it may be positive or sometimes it may be negative. And we'll do the table of measurement. We'll measure either diameter, length, breadth, anything which is required, and we'll do the 0 correction. After finding the mean from the table, we have to make the correction with 0 error. So this is step number 1. We have to find the vernier constant. So in our case the vernier constant was 0.01 centimeter, and this vernier constant may vary from vernier caliper to vernier caliper. And after finding the vernier constant, we have to find the 0 error. To find the 0 error, we have to find the 0 error 3 times, and we have to find the mean, and we have to consider the sign of the error also. Then we take the measurement. So suppose this is for a cube with length, breadth and thickness, so we have to make the table like this, and for length we have one mean length, and we have one mean breadth, and we have one mean thickness. Then after that we do the 0 correction for length also, for breadth also, for thickness also. And after finding the 0 correction, then we'll do the calculation. Suppose we are finding the volume, then we'll find the volume is equal to length into breadth into height. And you can use this link to do the virtual experiment with vernier caliper in O labs, but the vernier calipers in O labs don't have any 0 error, so that time you have to take 0 error to be 0. So link is given in the description. You can try this one, and please like the video and subscribe the channel. Thank you.